Here we have a question about static electricity and some electrical energy questions. So figure 1 shows a student after rubbing a balloon on his hair. The balloon and hair have become charged. So what you might know about the physics of that is the reason that electrons have transferred. So you might know that there's a friction force when you rub things together, and that friction can cause electrons to transfer from one to the other. The thing that gains electrons, the balloon in this case, is negatively charged. The thing that loses electrons, the hair in this case, will be positively charged. Okay, and when people do this question, quite often on part A, they jump into that because they see the diagram and they want to share the physics that they know. But the question actually says, describe the force. So it's because all that's happened and that these two are charged, there is a force. Okay, and the force that acts on the student's hair. There are actually two forces you can pick. You can either pick the force from one hair on another hair. Because all the hairs are have a positive charge, they'll have the same charge, they're repelling and pushing each other away. Or you could pick the force on the hair from the balloon. Because those two have opposite charges, they're attracting. Okay, so you can get 1 mark for saying an attraction between hair and balloon, or you can get 1 mark for saying that the hairs on the head repel each other. And the second mark is for saying either that is a non-contact force, okay, or that it's an electrostatic force. Then it was a little bit bad of them including that on a paper 1 question, because really contact and non-contact forces and types of forces is paper 2. But in this case, they do sometimes get a little bit of content muddled up. So an earth conductor is brought near the student, the charged student, and a spark jumped between the conductor and the student. So the reason that that happens is when the hairs are all positively charged, they have a load of potential energy, and when the electrons are all negatively charged, they have a load of potential energy. And there's a difference between the amount of energy in both of them, particularly because they're oppositely charged. And the electrons repel each other, they want to be spread out. So eventually the electrons jump the gap to neutralise, basically. So there's a potential difference between the two, and that causes an electric current to flow, which we see as a spark. Okay, so this is actually not too difficult of calculation because it gives us the terms potential difference, energy transferred and charge, and the equation you should have written down is energy transferred equals potential difference times charge. Now, as always in calculations, you should have a look and see if there's any you need to convert. Okay, so I know the standard unit for potential difference is volts. This is kilovolts, so I need to convert that. To convert from kilovolts to volts, we times by 1,000. So that is 2,500 volts. And then joules is the standard unit, so that's fine. Then I want to substitute my numbers into the equation. So my energy transferred is 0.0050, and that is equal to my potential difference, 2,500 once I've converted it, times charge. Okay, and I now want to rearrange this. So the number on its own on one side of the equals goes on top. So in that case, that's this small number. So we're expecting a very small answer, a small amount of charge. That makes sense in this situation. I wouldn't expect a big charge. So 0.0050 divided by 2,500 gives me 2 times 10 to the minus 6. Okay, so 0.0050 divided by 2,500 equals 2 times 10 to the minus 6. And unless it says gives your answer in standard form, you could choose to write that as a decimal. Okay, so times 10 to the minus 6, the 2 goes in the 6th decimal place. Okay. So 5 zeros, then 2. Again, put my answer on the answer line. And again, I would always encourage you to check by substituting that value back in for charge here, that final answer, doing your answer times 2,500 to check that you get 0.0050 back. Now this is a much more challenging calculation question, we can see, because it's 5 marks. So a defibrillator can transfer a charge to regulate a person's heartbeat. So you might have seen these on medical dramas and things, or possibly in real life, that they're used when people have had a heart attack and their heart is stopped. So when the defibrillator is in use, a potential difference of 4,800 volts is applied across the person's chest. And they show you the picture just in case you don't know what it is. You don't really need to know what it is. So a potential difference of 4,800 volts is applied across the person's chest. That's the standard unit. I don't need to convert it. Charge of 0.16 coulombs. That's the standard unit. I don't need to convert it. Passes through the chest in 4.0 milliseconds. Seconds is the standard unit. Milliseconds is not. So I do need to convert that. And that is 4 divided by 1,000, which is 4 times 10 to the minus 3, or 0.004 seconds. Calculate the resistance. So we've got charge and we've got time. We've got potential difference. We want resistance. So you probably want to pause the video, have a look at your equation sheet and try and figure out what equations to use here. And the ones we should be coming up with, charge and time, should instantly make us think current. So charge is current times time. I think your equation sheet might say charge flow, doesn't matter too much. Charge is the key word. And also potential difference equals current times resistance. So 0.16 equals current times 0.004. Rearrange that. 0.16 is on its own on one side of the equal, so that goes on top of the division. Okay, and I get a current of 40 amps. That is a very big current. You might remember when you did the resistance of a wire, any more than 0.5, it starts getting seriously hot. But we're talking about restarting a person's heart, so we want a big current. And then we need to substitute that value in here. So potential difference we have. So we write down 4,800 equals current. We've just calculated it. Okay, times by resistance. And again, we want to rearrange that for resistance. 4,800 is on its own on one side of the equal, so I divide that by 40. And that will come up with an answer of 120 ohms. I'm going to write the word so I don't have to find the symbol on the computer. And I write my final answer here. And again, I would be checking my rearranging. So I would be typing in 120 is my resistance. That goes in here. So 40 times 120, check I get 4,800. 40 is my current. That goes in here. 40 times 0.004, check I get 0.16.